Hi everyone, I'm Filippo Pini, young researcher at the University of Bologna, and today I will present you the Module 4 Behavioral System Dynamics Model for Sustainable Farming System Transition. During this module, we will understand how to analyze the system transition, so to understand how the system is shaped and how the individual behavior is shaped. Together, we will run some modeling activities in which we will merge the two dimensions, so the system dimension and the individual behavior dimension that can lead us to make a science-based and evidence-based decision making. Because we are in a complex system that evolve over time, so we need to understand how this evolution is shaped by these two dimension and how the behavior shape and is shaped by the system. Together, we will have our decision making. But who will be your teachers for this model? Together with me, we will have my colleague, young researcher at the University of Bologna, Arianna Dell'Olio, that will explain you the Unit 2 of this module. During the Module 4, we will answer these three main questions and many others, starting from how does the system behavior emerge over time. Will be the focus of the Unit 1 of this module. How can this system dynamics that we understand from the analysis of system behavior can be modeled and then simulated to have a analysis and understanding of the system transition. And the last but not least guiding question is how can the behavioral evidences be embedded and integrated into the system dynamics model to create evidence-based decision making and policy mixes. So just to give you an overview of this module, this will be the three units that you will encounter in the next phases of this module. So the Unit 1 that is focused on behavioral systematic models for sustainable farming transition. Unit 2 that is focused on system dynamic modeling, so the fundamentals of emphasis system dynamic model on Bensim software, and the Unit 3 integrating behavioral evidences and exploring policy pathways. So thank you for being here and enjoy the Hi everyone, I'm Filippo Pini, young researcher from the University of Bologna. And today I will present you the Module 4 Unit 1, the Behavioral System Dynamics Model for Sustainable Farming System Transition. During this unit, we will answer these three main questions. So, how does system behavior emerge over time? Which mechanism drive dynamics in complex systems? And to what extent does behavior influence these dynamics? We need to start from the analysis of how complex is the agri-food system. We should know that our agri-food system is characterized by interdependencies among actors, structures, and different level of dimensions. These interactions are characterized by non-linearity effect. So it means that it doesn't lead to B directly, but can be also indirect effect. And last but not least, some delayed effects. So it doesn't mean that what happened today create an effect tomorrow, but can create an effect in a longer time horizon. Knowing that, we need to move forward the linear thinking, where we assume that inputs drive to outputs. This is not the case of our agri-food system, as we already explained, because the complexity and the interdependencies, the delayed effect, and everything we already stated create these needs to analyze in a system perspective. So what it means that we have to consider and analyze the system as a whole, then quantify and analyze the interactions among the different actors and the different dimensions to understand the outcomes of this interaction inside the system. What does it mean? That the same system can produce different outcomes over time. Why? Because of the interactions, because of the different policies, and because of the different characteristics that can evolve during time. To understand this nonlinearity and the delayed effect, we need to start from a theoretical perspective, that is the system dynamic perspective. System dynamic is a perspective and a set of conceptual tools to understand the structure and dynamics of complex systems, as Sterman stated in 2000. What does it mean? That the system dynamics help us to move forward from a static representation of the system and then quantify the relationship that can help us and lead us to understand the different trajectories and the different scenarios, but also to avoid to use the linear thinking that is easier but not that effective. In that sense, the system behavior evolve over time, as we saw, and as with system dynamic say us, because we see a nonlinear effect. It means that the influence of a variable on another is not one-to-one, but can create a bigger effect than the input of the first variable, or a smaller effect. Going on, we need to understand that the system behavior emerge from the interaction. So emerge from the causal relationship that are stated in the static representation of the system that can be the causal loop diagrams, as we saw in the module 2. And is path dependent, because we have to consider what kind of interactions, where the system want to go, and which kind of actors deal with this system. So we have to consider these three dimensions to have the analysis, the bigger picture of the system and how we can create policy scenarios that are related to this system, path-dependent system. But why we need to move forward static representations? Because as we saw in Module 2, static representation as causal loop diagrams are pivotal to understand the evolution of the system dynamics, because causal loop diagrams analyze the causal relationship among the variables, among the actors, and the system as a whole. In that sense, we miss the two dimensions that are needed to analyze the dynamics of the system. So the time and the quantification of this relationship. How a variable influences another and is influenced by another variable. So we need to here to understand the change that move beyond the structure. From the system structure to the system dynamics, what is needed? Is needed to have the causal loop diagrams in which all the causal relationships are analyzed and designed. Knowing that, we need to quantify this kind of relationship. It means that we need a data set of influences among variables. In this kind of system dynamics, that is not represented by resources flow, but behavioral interactions, we need to understand how a dynamic influence on others. It means that, just for as an example, we need to understand how policies can influence the adoption of sustainable agricultural practices. How are these relationships? These relationships are characterized by non-linearity. It means that we need to arrive at a threshold. We shouldn't reduce too much the policies, because if we don't have a good layer of policies and then a mass of farmers that implement sustainable practices, the dynamics get slow. And then we can understand the system behavior over time, because these kind of interactions continue over time, year by year, and can deepen or improve the dynamics and the influence on each other. But how this change, the change propagates through the system? It propagates from the interacting influences between the system variables, as I already said before, and from the feedback processes that shape the system change. What does it mean? As we saw also here in the module 2, the feedback loop shape the dynamic of the system. Here we can see it easier and direct in a more direct way, because we see that the feedback loops that can be reinforcing or balancing a feedback loop can increase or decrease the effect of these interacting variables over time. And then the time dynamics, because as we already said, we are characterized by non-linear relationships and time-dependent relationship. It means that, as the example I already did, as if the policies that are implemented in 2025, policies for sustainable agricultural practice adoption, it doesn't mean that in 2026 we will have already an impact of these policies. We need to wait, let's say 3 years. It means that we have delays on that. We have to consider them in the system analysis. These delays drive to different relationship and to different effect over the other variables of the system. Also because we have accumulation of resources or behavior in general. So the system behavior emerge from the interactions and influences among the feedback processes over time. What drive the system behavior? The system behavior is driven by two different dimensions. The structural factors, so the economic condition, the policies, the market structures, the infrastructure, so at a macro level. And then also from the individual behavior factors. We can call it micro level. So the perceptions, social norms, social influence, the cultural dynamics, these interaction and interdependencies also here is pivotal to understand how the system is changing and how the system will change through the years. Because if we only consider system structural factors, we miss a really relevant part of the system, that are the people that influence the system and are influenced by the system. So the system behavior emerge from this interaction and influence among these two dimensions. Individual behavior, where is positioned, let's say, in the system, is embedded in the system. We have to consider it as part of the system, as the policies, the market structure, the infrastructures, the training sector, and all this part. The individual behavior is part of the system. In that sense, is not something exogenous, but endogenous of the system. Is influenced, as I said, is influenced by and influences the structural factors and the system as a whole. In that sense, behavioral and system processes can reinforce the change, create resistance to change, and also slow down the change. Just imagine, for an example, a policy that is not really welcomed by the farmers in some sense. We can say it as an example. If we implement these policies and is not really welcome, we most of all we'll see that the effect of these policies will not be the most impactful. On the other way, if we consider the perception, the social norms, the cultural dynamics of the target of these policies, and we, let's say, align with this target, we for sure will see a bigger effect, a higher effect on the system transition. So the behavior shapes how the system dynamics unfold over time. And to close, here the behavior shape also all the system trajectories that we will see in the next unit, in the unit 2, how this trajectory comes out from the system dynamic models. But the behavioral really can change how the evolution of the system can be. If something is, let's say, welcomed by the target people of a policy, we can see a reinforcing behavioral responses and then a higher effect, a better effect on the system transition, and the opposite. So what we want to do that here is to implement the behavioral perspective, the individual behavioral perspective in a system dynamic context.